Okay, so the second video I have here, it's still on quadratics. I wanted to do the calculator problems. So a lot of times in the calculator problems, they're going to give you the equation. So that becomes a fairly easy problem because all you're going to do is you're going to go to your graphing calculator and you're going to put that in. So I put in the equation, if I put that over here, negative 16x squared plus 80x plus 0.1. So get that into your calculator. You know it's going to be a parabola. It's going to open down because of this negative. So you know it's going to look something, it's going to start at 0.1 and then it's going to go up and come back down. So you know that's kind of what it looks like. So to get a screen, because the hardest part sometimes is trying to figure out the window, since it's an application problem, you know you want to start at time 0. And then just take a guess, like how long do you think this, a golf ball is going to be in the air? So maybe I say, I think it'd be in the air 8 seconds. So I'm going to go to window, and again, okay, I have 6 here, maybe I want to try 8. I pick a thing, 10 seconds, 8 seconds, maybe you think it's 4 seconds. But take a guess of how long you think it's going to take, and then instead of trying to adjust the y's, because I don't know how high that's going to go, I'm going to go zoom, and I'm going to go zoom 0, because if you look down at 0, it's zoom fit. That's going to fit your graph to the axis that I just did. So I hit enter on zoom fit, or you can just do zoom 0. I see, there's the parabola, and I put too much time in. This is 1, 2, 3, 4, 5, 6, 7, 8. So I probably could have went with almost 5, maybe 6. So then maybe you want to go back and say, all right, I went too long, so I'll do 6. Zoom 0. Just so you get a fairly good picture of what it looks like. It doesn't have to be perfect, but I see that there's the golf ball. The first question is find the maximum height. So if you want to use your calculator, what I need to do is find that maximum height. So I don't have a lot of room up there, so I'm going to go here, and I'm going to change my y maximum. I'm going to go 120 instead of 100 that it was, and hit graph. Now I've just got a little room up there to work with. I want to find that point right there. So if you go to second trace, there's something called maximum. So you go down to maximum, hit enter. It's going to say left boundary. So now you see that little blinking cursor. I need to make sure that's on the left side of my vertex. So it is. It's right here. It's on the left side. So left boundary, I'm going to hit enter. So that marks the left boundary. Then it says right boundary with a question mark. So now I'm going to come over here, make sure the cursor is on the right side of it. And it is. It's clearly right there. So I hit enter. And then it says guess. And if you want to, you can kind of arrow to where you think the highest point is, hit enter. And it's going to tell me the maximum is at 2.5, 100.1. So that means at 2.5 seconds, that's the t value, or the x value is your time. At 2.5 seconds, sorry about that. The x value, the y value is at a height of 100.1. So when the question says what is the maximum height, it's 100.1 feet. So that's if you want to use your calculator. If you don't want to use your calculator and you want to do it algebraically, remember there's a formula. The formula is to find this time, t is equal to the opposite of b over 2a, or usually we say x is equal to the opposite of b over 2a. So you would take negative 80 over 2 times negative 16, and if you take negative 80 divided by negative 32, you get 2.5. So that formula tells you the time, the x value, that you get to a maximum. So then to find this final answer, that 100.1 feet, I would have to plug that back in and take h of 2.5. So I'd have to take negative 16 times 2.5 squared plus 80 times 2.5 plus 0.1, and I would get 100.1 feet. So you could do it algebraically using this formula, finding the x value of your vertex and then plugging it in, or you can just do second calc maximum. Make sure that you have your boundaries on the left, your boundary on the right, and then your guess, and hit enter. Okay, if it asks how long is the ball going to hit the ground, again, when I'm looking at my graph, I'm looking at how long, the time it takes to get to right there. So if you're going to use your calculator, again, we're looking for that spot right there. If you go to second calc, that's called the 0. You're looking for the 0 of the function. So I arrow down, hit enter. Now again, it's going to say left boundary. So there's the point I'm looking for. So I can get a little bit closer, but I just have to make sure I'm on the left side of that point, which I'll hit enter. And now I need to get to the right side because it says right boundary. So get on the right side of that point, hit enter, and guess, just arrow over to where you think the 0 is. And it says it's at 5.00, so I'm going to round it to 5. Now this number, 1 times 10 to the negative 11th, means like 0.00000001. So that means it's very close to 0. So sometimes this won't say exactly 0, but it's as close to 0 as the calculator could get. So you're just looking for the x value. The x value is 5. So you would say it takes 5 seconds. Now again, if you want to do this one algebraically, you're looking to see when y is 0. So you would set that function equal to 0. When is the height equal to 0? And now you would have to use quadratic formula on that. You take the opposite of b, so negative 80 plus or minus the square root of 80 squared minus 4 times negative 16 times 0.1 all over 2 times negative 16. When you simplify that, you should get 5 seconds. Okay? Or I think that might even factor, I don't know. All right, so then let's talk about the other calculator one on this video. So this one is a word problem like the one up above, but you don't have the formula. So you're going to need to know the model projectile motion formula. So you probably would want to have that on your note card. And so basically it's similar to what we had up here. It's always going to be your height, h of t, is going to equal negative 16t squared. That comes from gravity, so that's not going to change. Plus your initial velocity, so it tells me the initial velocity was 32 times t, so it's initial velocity times time, plus your initial height. And it says it was released 4 feet above the ground. So again, that's my equation, so you'll need to know how to set that up. But it says if a football is 24 feet high, so I've got, again, I'll just make a quick little sketch of what this looks like. I started at 4, goes up, comes back down. There's my parabola of the rock being thrown. But it says the football is 24 feet high. So the football's up here somewhere, maybe at 24, I don't know where, but somewhere up here. I want to know, does it ever hit? Now, the picture might look like this. The picture might look like it actually does hit it somewhere. And actually, it might hit it in 2 spots. So if this is at 24, here's my parabola. I just have to decide, does this ever intersect? And if it does, what would that time be? So then I'd have to find those times if it does intersect. So I'm going to put that on the graphing calculator. I'm going to go y equals, whoops, I think I have it on this calculator. I'm going to put my y equals negative 16x squared plus 32x plus 4. Let's do 0 to 5 seconds. Let's go, and I'll do zoom 0. Get a picture of what that looks like. Went way too many seconds, it looks like. So let's go 0 to 2 seconds. Zoom 0. There's a little bit better picture of it. Okay, so there's the rock being thrown. And now I want to see where 24 is. So what I'm going to do is I'm going to go to y equals. I'm going to put in y equals 24. Because I want to know, where does this line go? Does it intersect that parabola or doesn't it? So I just have to go back to my window, make sure I at least go a y value of 24. So it started at y equals 4, and I want to go up to at least 24. So let me go to 30. I want to make sure that my y's go high enough so I can see what's going on. So now if I hit graph, there's the rock. Okay, and it comes down to the ground. There's 24 feet high. This parabola never gets to that point. So all I did is, this is the path of the rock. This is where the football is at 24 feet. It never reaches that height. So as an explanation, this graph, so the graph looks like this. This would be a good enough graph to show me that, okay, I graphed this equation. Make sure you write the equation. Here's y equals 24. That's how high it has to get. It never intersects. Now, let me change this. Let's say it was at 15, and I graph it, and it does intersect. If it did intersect, I can find the times when it does intersect by going second calc. There's an intersect button. It says first curve. Is that the equation of my first curve? Yes. Second curve? Yep. Second curve is just that equation. And then it says guess, so again, we arrow over. So we marked which one's the first curve, which one's the second curve, hit enter. So at 0.44 seconds, it would reach the 15 feet, and then I'd come over here and find that one. So if it would happen to cross, you could find out when it hits that point by doing a second calc intersect. Okay, so that's enough for this. I'll finish the chapter 3 in the next video.